Hey guys, so today we're going to be looking at a law that will help us solve for a triangle. And that means that we can use this to solve for missing angles and sides. And the two main laws are the law of sines and the law of cosines. But for today, we're just going to be focusing on the law of sines. So, what is the law of sines? Simply put, it's just sine of A over A equals, sine of B Okay, let me put that to the corner here. So what this means is that if we had a triangle that looks like this, and if this was angle A, B, and C, this would be side A, B, and C. Because remember, the angles and the side have to be corresponding and opposite. So these are all opposite, as you can see. So that means that the sine of this over this is equal to the sine of this over that, which is equal to the sine of this over that. So in which cases do we use the law of sines? This law is used for when the triangle presented is either a case of this or this, meaning that in the problem given to you, if the triangle follows this type of formatting, you would use a law of sines. And this should be clear from past lessons in geometry. But I'll put an example just in case. If the triangle looks like this, and they give you this angle, this side, and this angle, it would be ASA, angle, side, angle. And if they gave you this angle, and this side, it would be angle, side. So that. And if, let me erase this. And let's say it were angle, side, side. It would be like side, and this angle. So let's look at an example. It might be a little bit more clear. Here. Okay. Example 1. Let's say the problem says A equals 82 degrees, B equals 37 degrees, and lowercase a equals 15 degrees. So remember that remember just to have in the back of your mind, when the letter is lowercase, it represents a side. But when the letter is uppercase, it represents the angle. So now let's see. How would we draw this triangle? It would look like this. Let's say this was A, B, C. This would be A, C, B. So A is 82 and 37. And this is 15. So the problem is stating to solve for the triangle. And this means that you have to find the rest or the missing angles and sides. So the missing angle would be C right here, and then the side lengths of B and C. So first, this is the easiest part. Let's solve for C. And this does not even involve the law of sines. All you have to know is that the angles in a triangle add up to 180. So you just do 180 minus 82 plus 37, right? And that would equal to 61, which is equal to C. So we already know the angle of C, so that's done. All we have to find is B and C. And this is where our equation comes into play. So let's set this up. Put a little line here. So it would mean that sine of 82 over 15 is equal to sine of 37 over b, which is equal to sine of 61 over c. So to solve this, so this is basically a ratio. So when we're solving, we should probably look at this first and solve for b. And then using this, we can solve the second half of this ratio. So let's do that right now. So if we're solving the first half, so the part circled in red, it would look like this. And I got this just by cross multiplying right here, okay? And now we can solve for b, just using calculator. So b equals 9.116. So we got that. We know what the side length of b is. So now let's solve for c, so lowercase c, the side length. So let's do some cross multiplying here. So sine of, sorry, wrote that again, times c, right, equals sine of 61 times b. Or sorry about this. We now know that b is 9.116. Then we get that b is equal to, oh, I did this again, sorry. C is equal to 13.248. So now we'll solve for C. And you might be wondering why we used this, like the part I circled in green, why I had to use this ratio. But that actually doesn't matter. I could have set this equal to this. Because remember, all of these ratios are equal. So whatever I use, it'll work if it's correct, obviously. So there, that's one example. And now let's look at a second example, okay? And this example will be a little bit different because it introduces the angle side case, which is also known as the ambiguous case. So what this means is that an angle side triangle can sometimes not result in a triangle at all. So let's look at an example because it might make a little bit more sense. So let's say the triangle looked like this, okay? And this is not a 90 degrees angle, just making sure. Let's say it's 114, this is 12, and this is 11. So we'll set up our equation. Sine of 114 or 11 equals sine of, let's say you're trying to solve for this angle, okay? Sine of x over 12. So you set up the equation, you could do some cross multiplying here, and you'll get that x is equal to 85 degrees. And you might think this answer is right, but it's actually wrong because this is not a triangle at all. And it is because if you add up these two angles, 114 plus 85, you get 199, which is greater than 180. So that means this, again, like I said, it's not even a triangle. So that means there is no problem to solve, really. And this only happens with